Hello dear students, welcome to physics P1 class. Now in this video class I am going to start a new chapter, mechanical properties of fluids. So the mechanical properties of fluids, this chapter is from the branch of physics, fluid mechanics. What is fluid mechanics? The branch of physics which deals with the study of fluids is called as fluid mechanics. So first point arises here, what is a fluid? A substance which can flow is called as a fluid. Since you all know that the liquids and gases can flow freely, and hence these liquids and gases are collectively or combinedly called as what? Fluids. So the first point, fluid is a substance that can flow, and liquids and gases can flow freely, and hence these liquids and gases are combinedly called as what? Fluids. Now some of the important properties or the characteristics of fluids are: the atoms or molecules in a fluid are arranged in a random manner. A fluid has no definite shape of its own, and a fluid can exert or withstand a force in a direction perpendicular to its surface. So these are some important characteristics of fluids. So now the important point again is the branches of fluid mechanics. There are two branches of fluid mechanics. One is fluid statics and another one is fluid dynamics. So what is a fluid statics? Fluid statics is the branch of physics which deals with the study of fluids at rest, right? The study of fluids at rest is called as what? Fluid statics. Again, what is fluid dynamics? The study of fluids in motion. The branch of physics which deals with the study of fluids in motion is called as fluid dynamics, right? Fluid statics means what? The study of fluids at rest, and this is also called as what? Hydrostatics. Fluid statics is also called as what? Hydrostatics. And in this branch, fluid statics, we are going to discuss about the hydrostatic pressure, Pascal's law, Archimedes principle, surface tension. So these are the properties we are going to discuss in the fluid statics. And the fluid dynamics or hydrodynamics, here we are going to discuss about the fluids in motion. And in this branch we are going to discuss about the equation of continuity, Bernoulli's theorem, and viscosity, etc. Right? So what are the two branches of fluid mechanics? One is fluid statics, which deals with the study of fluids at rest, and fluid dynamics, which deals with the study of fluids in motion. Now the next one of the important physical quantity we are going to discuss here is fluid thrust, right? What is a fluid thrust? So let us consider here a block which is immersed well inside the water, as shown in the figure here. A block is immersed in a what? Well inside the water, as shown in the figure here. So what happens? The water exerts a force on all the surface of the block which is in contact with it. So whatever the liquid is in contact with the block, that liquid or the water exerts a force on all the surface of the block which is in contact with the liquid or water. The water also exerts a normal force on the walls of the walls and bottom of the container. So here again what happens, that liquid or the water also exert a force on the what? The bottom of the container and also walls of the container. So in general what happens here, a fluid always exerts a force on the surface to the normal in contact with it. So this normal force is called as what? Fluid thrust. So what we are going to define here, the fluid thrust, the total force exerted by a liquid on any surface in contact with it is called as the fluid thrust, or it is simply called as what? Thrust. So it is the total force exerted by what? A liquid on any surface in which it is contact with it. It is called as what? Thrust. And it is the force. Fluid thrust is a force. Thrust is a force, so hence it is a vector quantity. And the SI unit of force is Newton, so the SI unit of thrust is also a Newton. And the dimensional formula of fluid thrust is mlt minus 2, because the dimensional formula of force is mlt minus 2. So I think it is, the point is clear. What is a fluid thrust? It is what? The total force exerted by a liquid on any surface in contact with the liquid is called as what? The thrust. Thrust is a vector quantity because it is a force. It is the SI unit of fluid thrust is Newton. Now the next point is about the fluid pressure, or simply we can call it as a pressure. What is a pressure? We are going to define here. The pressure at any point inside a fluid is defined as what? Thrust per unit area around that point, or force per unit area around that point is called as what? Pressure. So the pressure or the fluid pressure is defined as what? The pressure at any point inside a fluid is defined as what? The thrust per unit area around that point. If a total force F acts normally over a flat area A, then the fluid pressure is defined as what? P is equal to F divided by A. Pressure is equal to what? Force divided by area. If F is the force, total force acts normally over a flat surface area, then the pressure is equal to what? P is equal to F divided by A. The pressure is a scalar quantity because of what? The fluid pressure at a particular point in a fluid has same magnitude in all the directions. So this shows that the definite direction is not associated with the fluid pressure. Because of that, the pressure is a scalar quantity. And the SI unit of pressure is equal to what? Force divided by area, Newton per meter square, or it is also called as what? Pascal. And CGS unit of pressure is dyne per centimeter square, and the dimensional formula of the pressure is ml minus 1 t minus 2, because of what? Force is mlt minus 2 divided by area is L square, so ml minus 1 t minus 2, it is the dimensional formula of pressure. Now the next point, we have to define about the one more physical quantity which is required to discuss about the next point. So what is a density? The density of any material is defined as what? Its mass per unit volume. That is equal to what? Density is equal to mass divided by volume. If a body has a mass m which occupies a volume v, then the density is equal to what? Mass divided by volume. Density is a scalar quantity. As liquid are incompressible, their density remains constant at all pressures. Density of a gas varies largely with pressure, because the gas occupies a space available for it. Now the unit and dimension of the unit and dimensions of density is what? The SI unit of density is what? Kg per meter cube. Kg per meter cube, that is density is equal to mass divided by volume, kg per meter cube. And CGS unit of density is what? Gram per centimeter cube. Then dimensional formula of density is ml minus 3. So these are the some important point related to what? The properties of fluids. Now the next one of the important derivation we are going to do here is the pressure exerted by a liquid column, that we are going to discuss here. So the variation of a pressure with a depth, we are going to do the derivation here. The pressure exerted by a liquid column. So this is the important derivation. For this we are going to consider here a fluid which is at rest in a container as shown in the figure, and its density is rho. And inside a liquid we are going to imagine here a liquid cylinder, a small cylinder. So inside the container only, we are going to imagine here a liquid cylinder. Its area is A and its height is h. So height of the liquid cylinder inside the container is h and its base area is A. Again, we are going to consider here the 2 points, point 1 and point 2. Point 1 is the top of the liquid cylinder and point 2 is the bottom of the liquid cylinder. And P1 is the pressure at the top surface and P2 is the pressure at the bottom surface. Now there are totally 3 forces are acting on the liquid cylinder. So totally there are 3 forces are acting on the liquid cylinder. Its height is h and its base area is A. As the fluid is at rest, the resultant vertical forces should balances the weight of the element. Right? This is the important point again here. So what are the 3 forces are acting on the liquid cylinder? The first one, the force due to the liquid pressure at the top surface. That is, the first one is first force is F1 is equal to P1 into A. F1 is equal to P1 into A, which is the force due to the liquid pressure at the top surface, and this force act in downward direction, right? Which this force act on the downward direction. Again, the second force is equal to what? F2 is equal to P2 into A. F2 is equal to P2 into A. This force is due to the liquid pressure at the bottom surface, which acts in the upward direction. So at the point 2, that is, the force acts F2 is equal to P2 into A, which acts in vertically upward direction, and P1 into A, which acts downward direction. And another one is the weight of the liquid cylinder, which acts vertically downward direction. So F is equal to M into G is the weight of the fluid which acts vertically downward direction. So there are totally 3 forces. One is F1 is equal to P1 into A, which acts vertically downward, and another one is P2 into A, F2 is equal to, which acts vertically upward direction. Again, the weight of the liquid Mg, which acts downward direction. Now in the balancing condition, or the as the liquid cylinder in the equilibrium condition, so what we can write here, P2 into A, that is upward force is equal to downward force. What we can write, P1A plus F. So P2A is equal to P1A plus F. This equation we have written in as the liquid cylinder in the equilibrium condition. So net force acting should be equal to 0. Then what we can write here, just rearranging the terms, just by taking P1A to the LHS, what we can write, and by taking the A common, P2 minus P2 minus P1 into A is equal to F, and F is equal to what? M into G, which is weight of the cylinder which is acting in downward direction. So just replace M by the equation rho H into A, because of what? Rho is the density of the fluid, then mass is can be written as what? M is equal to rho into V, because of what? Density is equal to mass divided by volume, therefore mass is equal to density into volume. Again here you can replace volume is equal to H into A. So H is the height of the liquid cylinder and A is area, therefore volume is equal to what? H into A. Again, the equation 1 can be written here by replacing M by rho H A. So equation 1 becomes P2 minus P1 into A is equal to P2 minus P1 into A is equal to rho H A into G. Now A and A get cancelled in LHS and RHS, then the terms remaining is equal to what? P2 minus P1 is equal to rho G H. So from this equation, from the equation to what we can write, or what we can give the conclusion here, the pressure difference between any 2 points inside the liquid is depends upon what? The distance between those 2 points, that is the H. So what is the distance between the point 1 and 2? H. So therefore the pressure difference between any 2 point inside the liquid is depends upon what? The distance between those points. And again it is depends upon what? The density of the liquid. It is depends upon what? Rho and H, right? Now again, if the point 1 and 2 are at lies at the same level, if p1 is equal to p2 at this case, so therefore p1 is equal to p2. If the point 1 and 2 are at the same level, then p1 minus p2 is equal to 0, or p1 is equal to p2. And if the point 1 is shifted to the surface, if the point 1 is shifted to the surface, then the what is the pressure acting on the surface, that is equal to the atmospheric pressure, right? If the point 1 is shifted to the top of the liquid surface which is open to the atmosphere, therefore the pressure p1 is replaced by the what, atmospheric pressure, and p1 by p2 by p, then equation 2 can be written as what here, p minus pa is equal to rho gh, right? Where p is what, the pressure at the depth h, and Pa is the pressure at the surface, atmospheric pressure, and it is equal to rho gh. So again the final equation what we can write here, P is equal to Pa plus rho gh. So the total pressure at a depth h below the surface of the fluid is called as absolute pressure. So here P is equal to what, absolute pressure, which is equal to the what, the atmospheric pressure plus the pressure at the depth h, that is equal to what, the absolute pressure. So P is equal to Pa plus rho gh, and the difference between P minus Pa is equal to rho gh, P minus Pa is equal to rho gh. So this one is called as rho gh is called as Gauss pressure, and P is equal to Pa plus rho gh, it is called as absolute pressure. So this is the important point related to the liquid pressure what we have discussed here. Rho gh is called as what, the Gauss pressure, which is equal to the difference between the absolute pressure minus atmospheric pressure. Here P is absolute pressure, Pa is atmospheric pressure, and rho gh is Gauss pressure. Therefore the Gauss pressure is equal to difference between absolute pressure minus atmospheric pressure. The next important physical quantity I'm going to explain here is about the hydrostatic paradox. So what is hydrostatic paradox? Now you can see here the figures. Let us consider here the 5 vessels of different shape as shown in the figure here. So here we have the 5 vessels, all of them have the what, the different shape. So all they have filled with what, the water with the same height, or a liquid with the same height. The pressure at the base of each vessel is same regardless of the shape of the vessel. If the shape of the vessel may be different, but at the same height h, all the vessels at the same height h shows the same pressure. So that is called as the hydrostatic paradox. The pressure at the base of each vessel is same regardless of the shapes of the vessel, right? The pressure exerted by liquid depends on the height of the liquid column only, and it is independent on the base and shape of the containing vessel. This is known as what, the hydrostatic paradox. So hydrostatic paradox means what, the different amounts of liquids or the fluids exerts the same pressure at the same depth is called as hydrostatic paradox, right? So as we have shown here, what, the different vessels, the vessels of different shapes, they are filled with the liquid with the same height, but the pressure at the base of each vessel is same regardless of what, the shape of the vessel. Shape may be different, but the same height h, all the vessels shows the same pressure. That is known as what, the hydrostatic paradox. The pressure exerted by liquid depends only what, the height of the liquid column, and it is independent on what, the base and the nature of the base and shape of the containing vessel. So the definition of hydrostatic paradox is the different amount of liquid or the fluid exerts the same pressure at the same depth is called as hydrostatic paradox. So in the today's video class, students, we have discussed about the important points, that is the introduction part. We have in the introduction part we have given about what is fluid statics, fluid dynamics, what is fluid thrust, what is pressure, right? What is density, and one more important derivation, that is the variation of pressure with depth. So all these points we have discussed. In the next video class, we're going to discuss about the next point related to mechanical properties of fluids. Thank you, students.